So we spoke a lot about how these antimicrobials work against bacterial cells, but how do we know like what concentrations? When we say like, hey, 200 ppm works well, how do we know that 200 ppm works well? So, well, we do this by testing the antimicrobial efficacy of these compounds. Now, if you go to the EPA website, they have a bunch of protocols that help you figure this out. Um, One of the most common ways is basically you take a certain amount of microorganisms, and then you hit it with your sanitizer. If and if you get like above 3 log reduction in like in a minute, 30 seconds to a minute, that's considered a like a good sanitizer. A disinfectant will give you above 5 log reduction. Again, disinfectants can be either general or they can be broad spectrum. And then if you have complete reduction, then that could come under, and you can also eliminate spores, then that comes under a sterilant. But how do we find out the efficacy of this? One of the methods is called the MIC, or the minimal inhibitory concentration. So basically in this test, what you do is you take a really high concentration of your antimicrobial. Say you take chlorine, and you take 2000 ppms of chlorine, or say even 4000 ppms of chlorine, and then you start diluting it. So from 4000 to 2000, 2000 to 1000, 1000 to 500, 500 to 250, so on and so forth. So you can go down to really minuscule levels, and then you can introduce bacteria. If you usually for these tests we introduce 5 log CFU per mil of bacteria, and we find the lowest concentration at which the bacteria, and then we add a growth medium. So we find the lowest concentration that inhibits the growth of the bacteria. So that is the MIC. So the lowest concentration at which bacterial growth is inhibited is called the minimal inhibitory concentration. There's also a minimal bactericidal concentration. It's the lowest concentration of an antimicrobial agent required to kill a particular bacterium. Usually, we look for the lowest concentration at which there is a 3 log kill in the population of bacteria. So the MIC and MBC are very important. And then the MIC we can find out how tolerant an organism is, because certain strains can be more tolerant, or certain mutants can be more tolerant to certain antimicrobials. So that's why this is an important test for the food industry. So how do bacteria resist or tolerate antimicrobials such as sanitizers? Now, even though sanitizers are commonplace in the food industry and are used in almost every step, foodborne outbreaks continue to happen. And sometimes these outbreaks are large-scale, multi-state outbreaks where thousands of people get infected. Right now, there's a Wendy's outbreak. I think it might be contaminated lettuce. In around Ohio, there's been an outbreak in Wendy's because of the consumption of contaminated produce. So one of the methods, so bacteria uses several methods to increase their tolerance to sanitizers. One of the most common methods is the formation of a biofilm. So if you look at the picture to the right, you see this like a mat of microbial cells. This is called a biofilm. A biofilm is basically a community of microorganisms that is encased in a polymeric matrix. It's called the EPS, exopolymeric sheath, or exopolymeric substance. So biofilms reduce sanitizer efficacy by reducing contact between the sanitizer and the microorganism. Biofilms also have a really high organic load, so when the sanitizer comes in contact with the biofilm, it is neutralized because of the organic content. The microorganisms in a biofilm there are these channels through which they push out chemicals that they find harmful or deleterious. So it almost acts like a tissue. Even in bacteria individually, there are these pumps called efflux pumps that help the bacteria pump out bad chemicals. And all of these can help the bacteria survive, resist the sanitizers. So in certain studies, they have found that bacterial biofilm populations on stainless steel were reduced by 3 to 5 log by chlorine sanitizers. In contrast, the planktonic cells were reduced by 7 to 8 logs. So when they got a complete kill, when you use regular cells just suspended in medium, but when you have a biofilm, it seems to resist these antimicrobials really well. And this is why in hospitals with Pseudomonas is a big issue. Nosocomial infections are a big issue because Pseudomonas, as we had discussed before, can cause spoilage of food, but in humans it can cause respiratory illness, and it can form a biofilm on any surface, including like taps, on sinks. We have also found like Pseudomonas form a biofilm mat on sanitizer, on bottles of sanitizer itself. That's how strong Pseudomonas is in surviving this chemical challenge. So as we know, sanitizers are these chemicals that can be used to reduce bacterial population. This sanitizers and disinfectants can be used to reduce bacterial population on food contact surfaces. Um, Now, sanitizers are reviewed and approved by the EPA, the Environmental Protection Agency, and the Food and Drug Administration. The EPA reviews efficacy and safety data and product labeling information. So if you make a claim that your sanitizer or your disinfectant works really well against salmonella or against salmonella biofilms, you will have to actually conduct tests where you grow the biofilms on these stainless steel coupons, and you have to show them data that your sanitizer is able to reduce a certain level of bacteria from those coupons. So so that's so that's what the EPA does. It reviews, it looks at the product labeling information. The FDA is primarily involved in evaluating incidental residues of food additives from sanitizer. So that includes if you use too much chlorine and it's there, you don't rinse off your product, the FDA can ding you for that. The antimicrobial agent and its minimal usage level for direct use on food and on product contact surfaces must be approved by the FDA. So both these regulatory agencies have really important roles when it comes to the use of sanitizers in the United States. Now, again, there are many regulations and recommendations associated with sanitizer use. Obviously, this is a science, and optimal use of a sanitizer is very important, not only to reduce microbial population, but also keep the consumer safe and also prevent the bacteria from becoming tolerant or resistant to the sanitizer. So there are certain regulations when you are using water for produce or food contact surface, you have to use water that is potable or that meets potable water standards for mixing the sanitizer. The National Organic Program approves chlorine's use for post-harvest management, but restricts the residual chlorine levels in the water at a maximum of 4 ppm of chlorine. So that's very less amount of chlorine that they can use. And all companies that use these sanitizers must have standard operating procedures. An example for a SOP for a post-harvest water sanitation for dunk tank is one, you have to check, do we have potable water? Second, did we maintain and monitor record sanitizer levels in all the flumes, dunk tanks, and in every single pass of water is also monitored. Monitor and record temperature of dump tank and flume water as well as pulp temperatures to prevent infiltration. As we had mentioned, the temperature of the water is very important, and so is the pH of the water, the hardness of the water. Also, if the temperature of the fruit is really high, the difference in fruit temperature and water temperature can make the water enter into the fruit, so and that way cause internalization of microorganisms. So we have to, so for a successful operation, they have to monitor and record many parameters such as pH, the turbidity, the amount of free chlorine in water on a regular basis. and all of these are integrated into their standard operating procedure. So the summary of the stock is, as we have discussed, sanitizers have a interesting and sometimes often sordid, macabre um, uh, history, but they are critical to the hygiene and safety of our foods and the hygiene of our food contact surfaces. Washing of produce is done to reduce cross contamination. Some of the factors that are taken into consideration while choosing a sanitizer is the cost, the efficacy, the toxicity, and sanitizers are effective when used only in ambient conditions. Under abuse conditions, they can even become dangerous and explode. Organic load parameters such as organic load, pH, water hardness, temperature are very important to be monitored throughout the whole cycle where a sanitizer is used. A good standard operating procedure should be detailed and clear.